Hello everyone. In this video, I'm going to start talking about word embedding. So here we'll understand the importance of vectorization. So we will start with the count vectorization, which covers bag of words model and ngram model. Before getting into word embedding models, let's understand what is word embedding, right? So we know that machine learning models does not understand any kind of a text or a words or a string or whatever you call it, right? All it accepts only the numbers, right? So could be a fractions or could be integers, doesn't matter, right? So if I have a text, since we are working on a natural language processing, which deals most of the time, or I would say all the time, the languages only, right? So since I have a language and I need to pass it to the model and do some kind of a processing and generate a output. It all depends upon what exactly we want to generate, or it could be a prediction, or it could be similarity, or it could be anything, right? So all I have is basically a text. So, and my machine doesn't understand anything or ABCD of a text, right? So I need to find a way that, something that I need to use which can convert my text into some numbers, right? So that is where this word embedding comes into a picture, where we use multiple models, multiple techniques in a word embedding, which will help us to convert a text into some kind of a numbers, right? So that numbers are nothing but a vectors, right? In general term, we call it as a words or a text, but in technical term, we call it as a vectors, right? Some kind of a vectorization we are going to do in this word embedding. So after that, we can feed it into a model, all right? So that is what is basically the, at high level, word embedding. So let's start with the first technique, that is a count vectorizer, right? So when I say count vectorizer, it uses two of the models, right, within the count vectorizer. The first one is basically the bag of words model, and the second one is a ngram model, right? So with the help of these guys, we will be able to convert our text into some numbers. All right, let's see that how we can use that. So let's talk about the bag of words model. Bag of words model is used in NLP to represent the given text or a sentence or a document as a collection of words without giving any importance to grammar or the occurrence order of the words. It keeps the account of frequency of the words in the text document, which can be used as features in any models. So what it means that, suppose I want to store this statement, right? So what happens if I want to store those guys, all this data into this bag? It doesn't keep track of the occurrence or like how the data is coming here, right? So the way how it stores is it doesn't give any importance, right, to the grammar. So like I went to have a cup of coffee, right? If I want to store this data, it is not going to store something like this. I went to have no. So it can store however it wants. So without giving any importance to the grammar. Maybe I took up, went, I, but, right? It doesn't care anything like that. So that is how the data will be stored here, right? So, but it keeps the account of frequency of words in the text document. It means that how many times I is occurring, how many times went is occurring in this given text. All right. So how many times cup is occurring. So, and the same thing here, text to, right? So if I want to use these guys and convert a bag of words, right? So text one, bag of word one. So you can see this I is occurring two times. So that's where you see I2. Went is occurring one time, and to, have, so and so forth. Similar thing in this guy. So I is occurring only one time. Don't occur is occurring only one time. So similarly, it will keep the count of each word. So that's the name, as we see, count vectorizer. All right. So then, why bag of word is mainly used? So bag of word is mainly used for a feature selection. The above dictionary is converted as a list with only the frequency terms there, and on that basis, weights are given to the most occurring terms. It means that, let me take these guys away. So it means that, so in our general, whenever we are speaking or in any article or a paper, wherever you see, so most of the time, some words will keep occurring. Those are nothing but a stop words that we have discussed in our earlier video, right? So in this bag of words model, whichever the words are occurring more number of a times, it will be, it will give a more importance to such words, right? Something like a stop words. So since they occur more number of times, and more importance will be given to the stop words. So something like I, you, in, where, it, right? What, something like that, right? So that is how the bag of words model will keep count, all right? And it will give more importance to the words which are appearing more number of times in the text or in the document, whatever you take, all right? So, but the stop words are the most frequent words that appear in a raw document that we know. Thus, having a word with high frequency count doesn't mean that the word is as important, right? As I said, suppose say I is appearing 20 times in the total of 100 words. So it doesn't mean that I is very important, right? Doesn't mean that I is very important. So then the real value will be missed there. The real value of any words, right, in the document, we will lose that importance, because it's keep giving importance to only such words like a stop words. So to resolve this problem, there is something called a TF-IDF was introduced, right? Anyway, we'll discuss that later after a count vectorizer. So, but the idea is how the data will be stored, how the vectors will be stored in bag of words model is based on the frequency of the words. All right. So that is basically bag of words. Now let's understand a ngram model. Let me pull this guy a little down. Okay. Okay. So what is an ngram model? Right. So ngram model is basically, again, let's understand. So there is something called a 1 gram, 2 gram. Let's start with that. Okay. As discussed in bag of words model, bag of words model doesn't keep the sequence of words in a given text. Only the frequency of words matter, right? That is what we have discussed. It doesn't take into account the context of the given sentence or care for the grammatical rules that we have understood, all right? Now, let's understand this n-gram. Okay, so n-gram is the sequence of n words from a given text or a document, right? So it will like a n-gram model is used in such a cases to keep the context of the given text intact, right? In a bag of words model, we don't keep that context intact, right? But in n-gram model, we do. And what is this n-gram? So if n equal to 1, we call it as a unigram. If n equal to 2, bigram. N equal to 3, a trigram, right? So that is what the n-gram, right? Now let's understand how it works actually. So as you can see, there is a text, right? The same text what we have discussed in the BOW. So when I say unigram, it is exactly same as a word tokenize, right? It exactly same as a word tokenize, where I is one word, went to have a cup because it is a 1 gram or a unigram, right? So as you can see, this is a unigram. And I say bigram, let me take this guy. Okay, give me a second. Take a little on this. Okay. So when I say bigram, so first it will take a two words. I went because it's a 2 gram or a bigram, and the two words equal to 1 gram here. And the next two words will start from the last or the ending word in the first instance, and went to, then to have, right? Then have a, then a cup of coffee, coffee, but I ended up having lunch with her, right? So that is basically the bigram. And if I talk about a trigram, yes, most of you would have guessed it. It's exactly same, right? So trigram 1, 2, 3. So this is going to be 1 gram here whenever I say trigram or 3 gram. Similarly, the next trigram is basically, so went to have a, right? So have a cup of coffee. So here it is keeping the context intact. So whenever I say no, just a cup, so what is the cup? So I can say cup of coffee in a trigram. So this will make little sense, right? So in the trigram, we can make sense out of it. So that is basically a trigram, right? So whenever you start typing a mail or something in a Google or a Gmail, so you will say that whenever you type a HOW, so there are some suggestions will keep coming. So suggestions are like, how are you? So these two words will pop up, right? So you don't need to type it. You can just press a right arrow mark. So you'll be able to, this data will be filled up for you, right? It means that this is a trigram where the model has been trained on this data more number of times. So that is why you will keep seeing this kind of suggestions in your Gmail. So it depending upon what data, what a text you are going to write. So based on that, how a model was trained before, accordingly you will keep getting the suggestions, right? Whichever is occurring more number of times or like more number of times used. So those data, those suggestions you will keep getting. All right. So let's do one thing. Let me take this guy and move. So what we'll do, we will try to, there is something called a skip gram, which is rarely we use. So it's just that one skip 2 gram. So in this case, I don't understand, right? What is the problem here? So here I skip don't, one skip and 2 grams. I understand, right? I understand. Next time I will use a don't, skip understand, and what, don't what. So that is a skip grams. All right. Now let's use Python and see how these things will work. All right. So here I have a bag of words. So here what I'm going to do, I am going to import count vectorizer. This is what we are learning, one of the word embedding technique. Count vector is what I'm going to use. So this is available in sklearn.feature underscore extraction.text. Right, a little lengthy, but yeah, that's how it is. So importing a count vectorizer, then I will import a stop words. This we have seen. And pandas, yes, we know that. So this is basically a text. So this is an example of bag of words. Some document or a sentence, however you can call it. It is in the string. Now I will instantiate this count vectorizer over here, and this is my object now, vect1, and I will use this vect1 and say dot fit underscore transfer method, right? So this fit underscore transfer method will take this guy I'm passing here, and I will get the feature names. Right, I will get the feature names. How do I get? I use the same object vect1, and I have a method called a get underscore feature underscore names. As we have understood, bag of words model is used to get the feature names, right? And that is what we are trying to do here. Get underscore feature names. So then finally, let's execute this. Clear this. I'm going to execute. It's executing. Still okay. So you can see this is a bag of words. This is how the data has been stored. It is in ascending order, right? It is in ascending order. It doesn't care where is the grammar and things like that. It just save the data something like this. And the vocabulary method, right? The vocabulary method gives the indexes for all these bag of words. So an is basically 0 index, bag is index 1, so on and so forth. This is basically the vocabulary underscore. All right. So let's see what and all we can understand going forward. So now I have a count vectorizer, one more count vectorizer. So let's keep this guy just for some time, then we'll come back to this, right? So I have a count vectorizer. Again, I'm reinstantiated, and I will say this object dot fit. Fit what? Fit this data string, right? So that is a string here. I'm going to fit, right? I'm going to fit that data. So now I have a one more string, that is a string 2, right? So this is let's understand is of words is. Okay, it doesn't make any sense. This is just to show you, example that how things will work, right? So this is another string, and what I'm going to use, I am going to use this guy c underscore vect, which is already trained here on this string, and now I'm going to say dot transform here. So when I say transform, I'm going to use this string 2. This is trained on what? This is trained on the first string where we have this data, right? So this is a bag of words example. Now I'm transforming with the, by passing this data, and that data is stored in this new object called cNewVect. Now what I'm going to do, first I will take this guy cNewVect, and I will pass it to, I will convert into an array, to array, right? And here I am again calling this guy, sorry, my bad, not this guy. So this vect1, right? And I'm getting the feature names. Feature names are basically, this is an example that we have seen already. So I'm checking this text, how many texts available in this features. Features are what? Features are nothing but a text only, right? I'm passing this and checking whether this data is available in the original string or not. All right. So now let's see. Let me execute. We can see here that text present at in this guy. So an is not present here. No, that's why 0. Bag is not present, 0. And what is that? Example is not present, 0. Right? 0, not present. And is, right? Is occurring 2 times, 1 and 2. Right? It is at this index position occurring 2 times. Off, yes, off is occurring 1 time. This is not occurring, and words, yeah, occurring only 1 time, and you can see only 1, right? So these are the original indexes. These are the bags, assuming that these are the bags, word, text, now maybe thousands of lakhs of millions of text here. and the new text comes in, right? Any data, any text. So I'm going to use this bag of words and check how many words are present in whatever in this new text, how many words are present in this bag of words, how many words and the frequency of each word, right? So that is how you can interpret this bag of words model. All right. So I hope you got idea here. Let's move on. Now I can use the stop words. In the count vectorizer itself, I have a stop words parameter that I'm going to use, right? So here I'm importing the stop words, instantiating stop words into STP words. And in the count vectorizer, I have a stop words parameter, then I'm calling this stop words. Then when I print it, so when I print this, so these are all the stop words that we already have. So here I can make use of that parameter available in the count vectorizer. So I don't need to specifically take care of the stop words, removing the stop words and things like that. So now vect1, let's see that fit underscore transform, again a string. This is a string here. Then get the feature names, right? And the vocabulary, I'm going to print everything. So now what is happening here, right? So here we have get rid of the stop words, right? So it's supposed to be, this is an example of bag of words, but what we are seeing here, bag, example, and words. Only 3 words. That is because we have used the stop word when I'm instantiating a count vectorizer. So if I mention this parameter, right? So whatever the stop words available in this string will be removed, and the important words only will be printed. All right, because this is vect1. Here I said vect1 dot fit transform. So that is the reason I'm not able to see those stop words which are available in the string. All right, let's move on. So using a function. So how can I do the function? So this is the function and I have a message. These are the arguments. Message is one argument, count vect is another argument. So here I am going to pass a model here, right? In this case, and here I'm going to pass some text. So then this model will be passed here, and I will say fit underscore transform, and this message I'm going to pass, right? So the whole thing will be, instantiated into this particular object, terms underscore doc. Then I will use this terms underscore doc, convert into an array. Then columns. So columns basically what? The features. We know that how to extract the features, right? Count vect is basically whatever the model I'm going to pass. I will say dot get underscore feature names. As you can see, get underscore feature names. These are the features. Similarly, I'm going to get the features. All right. Finally, I'm converting into data frame and I'm returning it. This is a simple function. So this is, I think, everyone would have seen this, how to define the functions and things like that. Same concepts are going to be applied here as well. So let me execute. And now this is my message. So that message is over here, and count vectorizer, and this is an object. Now what I'm going to do, I'm going to call this particular function, that is text underscore matrix. When I'm calling this particular function, so I'm going to pass 3 arguments, right? Message is 1, and this is a vector, C underscore vector, right? So these 2 argument data I'm passing here, and we know what is this message. This is guys here, and C vect is count vectorizer. Now when I call that, you can see that data will be passed, will be passed here, and this guy will be passed over here, and this guy over here, and this message will come over here, and we do all this processing, and you can see all these are the features. And what is 0, 1, 2, 3? 0, 1, 2? 0, 1, 2 are basically, this is the 0th index, first document, and this is the second document, and this is the third document. Right? That is why you see 3 documents, 0, 1, and 2. And how to interpret this table. So here we see that in the 0th document, that is nothing but this guy, is ARE present, R present. Yes, it is present. How many times present? I see only one time. Yes, only one time. Is but present? No, it is not. For, get, in, is. So all these words will be checked in the each and every document accordingly, and it will mention how many times they present. Right? If it is not present, it will be 0. If it is present, and how many times. Here you can see slowly appearing 2 times. Right? In which document? The very first or the 0th index. That is how you can see that. All right. So that is basically bag of words model approach. Now let's understand ngrams. Right? So let's understand ngrams here. Now I'm going to import the same guy, count vectorizer, because ngrams is part of a count vectorizer. Then here I will import a word tokenize because I have to, okay, let's see that how we can make use of that later. All right. So first, the very first string is, this is an example of gram. So now what I'm going to do, I'm going to instantiate count vectorizer, this guy, and here I have a parameter ngram range. Right? Ngram range is 1 to 1. Right? 1 gram. And this is a vect1. I will say fit underscore transform. I will pass this string. Here the idea is that how to print 1 gram, bigram, or unigram, bigram, trigram, and 4 grams. Right? We are going to use the same text again and again, and we are just keep on changing the grams here. Right? So count vectorizer will have vect1 is having a 1 gram, vect2 is having a 2 gram, vect3 is having a 3 gram, and 4 and 4. So for everything, I'm just saying that fit underscore transform and passing this string. Now finally I'm printing here vect1, vect2, vect3, and vect4. This way 1, 2, 3, and 4. Right? So let's print and see how the data looks like. As you can see that the 1 gram is basically only one data, one word, and example, gram is of this. This is coming from vect1. That is nothing but this guy. And for a 2 gram, an example of is an half gram. This is right. An example of gram. So basically, this is how it is going to be printed. And a 3 gram, 3 words equal to 1 gram. 3 words equal to 1 gram. So the same way what we have discussed, the same thing you can see here. All right. If you have a 2, 3 here, so first 2 gram, first bigram, then trigram, then bigram, then trigram. So this is how it is going to be printed. All right. So that's all about the count vectorizer, where we understood bag of words model and ngram approach. So in the next video, we will see some other techniques, which are again a part of our word embedding itself, and we'll understand more concepts. Thank you for watching this video. Keep learning. Thank you.